calling you. The universe is calling me. It speaks both day and night. It's full of dark and light.
Hey, hello, and welcome to SkyTour Radio. It's another fun-filled Sunday night. We're going to spend the next couple hours having a ball together. I'm your host, Mark D'Antonio, and I'm here with my amazing and outstanding co-host, one of two. First is Amanda. How are you, Amanda Curran?
I'm well. How are you, Mark?
I am fine, thank you.
Wonderful.
And we also have Daryl Mason with us. Daryl, how are you?
Hi, Mark. I'm good. You? And hello, Amanda.
Hi, Daryl.
And hello, everybody out there. From all of us at KGRA, we want to thank you for being our wonderful, dedicated audience. You've made our show one of the highly rated shows that it has become at kgraradio.com, and we're very humbled and proud of that. So we will continue to bring you awesome data and awesome show content moving forward. You know, if you want to listen to the radio, that's one thing, but if you want to actually see astronomy in action, which is what our show is about, you can always subscribe to our companion stream for free on YouTube. It's called SkyTour Livestream. And what is STLS? Well, it's a clear night journey into the wonders of the deep sky, courtesy of research-grade telescopes here at the John Zach Memorial Observatory here in Connecticut, and soon in Arizona, out in the Sonoran Desert at an observatory that will, again, we will reveal the name of the new observatory in the coming weeks. In SkyTour Livestream, we show you the universe that you cannot see, remnants of dead and dying stars, faint nebulae that are now bright and glistening in the eyepiece that you see through the camera as we see it all, glittering jewel boxes of stars and rich clusters and wondrous phenomena in the universe like stellar nurseries where life itself may eventually arise. And we see these wonderful periodic interlopers like we have just seen Comet Neowise. Daryl and Amanda have both been with us when we've gone through SkyTour Livestream and showed everybody Comet Neowise as it came and went in our solar system, not to return for over 6,500 years. And that's all courtesy of SkyTour Livestream's telescopes and cameras. And it's also a stream where you guys, all of you watching and those attending the stream, can be in charge. Yes, that's right. If you guys want to tell us where to go, well, you can always tell us where to go. But you could also say it nicely if you have an object you want to say, like, show me a green nebula, or show me this really cool nebula. Wasn't there this thing in the sky that we could see one time before around here? And if you don't know, we'll tell you. We'll show you and ask you what you'd like to see. Of course, we always have things to look for. But you're welcome to join us and have an amazing time with us. We always have a good time. And that's what SkyTour Livestream is all about. Again, it's on YouTube. So look for SkyTour Livestream. All right. And join us. It's free. You can also pick up the book, The Populated Universe, which is available in 3 formats and soon to be 4, which I'll tell you about momentarily. 3 formats for 3 different budgets. There's a large book, all full color. There's a smaller black and white version. And then there is an ebook if you want to get the ebook. The 4th format is the audio book. That's right. The audiobook is now being done, and I've listened to one of the chapters already, and I am just amazed at how, it just pulls you right in. The reader is an amazing person, and so I think you will appreciate how she delivers the message of the populated universe. And SkyTour Radio now has a call-in line if you'd like to call in. It's sponsored by the Paranormal app found on Google Play and on iTunes, and we'll be opening the lines perhaps a little bit later, maybe in the last half hour of the show, and our show does go from 8 p.m. to 10 p.m. Eastern Time. And the phones will not be answered until we start taking the calls tonight, so we'll let you know, all right? And if you want to email us, you can always email us at skytourradio@kgraradio.com. So tonight on SkyTour Radio, we're gonna sort of put aside the exoplanet roundup because, in a sense, the entire show is a sort of about exoplanets as we go along. You'll see why. But we have some astronautes that I want to mention first. And some of these, I want to also thank Amanda, our very own Amanda, because she is the one who dug up some of these really cool stories that she thought were very interesting. And so we're going to talk about them briefly. And I want to thank you, Amanda, for doing that, by the way. Just so you know, I mean, that was very nice of you.
Well, I had my own selfish motives. I thought they were kind of interesting, so I passed them on to you to sort out and then explain back to me and answer all my questions, so I didn't have to strain my brain trying to make sense of it all.
Well, I think that's what Skytour Radio is all about, right? Is to try and take the complex and make it understandable and palatable to other people who may not have a strong scientific background or who are interested in the worst way, but just need to have it explained in a way that they can grasp onto.
Yeah.
And that's kind of what I like to do. That's sort of like, I guess if I'm an idiot savant with anything, it's that. I can do that. I can take the complex and make it simplified for people, to digest, and everybody has a strength, and maybe that's mine. I mean, time will tell, right? But we'll see. Now, one of the things that you gave me, Amanda, was one that I thought was really interesting. It's called the Lunar Laser Ranging Retroreflector Experiment. And this retroreflector experiment was left by many of the Apollo missions, I believe, on the moon. And it was a bunch of little, what are called corner reflectors, or little round reflectors that no matter which way the light hits them, they will reflect back a certain amount of light back in the same direction that hit it, okay? So if it was at a glancing shallow angle, you'll get some light back along that glancing shallow angle to the source. Now, that retroreflector experiment is interesting to me because, as most of you know, I got a degree in astronomy years ago. And the retroreflector experiment was actually built at my university. And so there is one actually in a case in the university. You could walk in, and there it is inside a big glass case. And there's a beautiful moon set there and everything. And it's 1-to-1 size. It's a full-size version. And you can see it. And so this retroreflector system has been up there for 50 years. And 50 plus. And so we were getting signals back. And why do we do it? Well, we aim a green laser at the moon. Green is actually a laser color that can penetrate the atmosphere pretty well. Okay, so the green goes all the way to the moon, comes back, and based on that round trip time, just the timing, we know the speed of light. So if you know the time it takes for that light to go to the moon and back, you can get within millimeters the distance to the moon. Okay, it's through experiments like this that we figured out, for instance, how exactly far away the moon is and how far it might be leaving the Earth's orbit over time. It only goes about 2 centimeters a year. And so you can imagine it's going to be quite a while before it leaves the Earth's influence altogether. In fact, that time is so long that the moon will not be out of the Earth's orbit. Out of its orbit around the Earth until such time as the sun has died. So it's always going to be with us for the rest of our existence. All right. But the problem is with these retroreflectors, the signals have dropped to less than 10% coming back from if you can imagine a certain component of the light coming back is, say, the 100%. Well, it's dropped to 10 times less than that. Over time. Now, it used to be a lot more, and astronomers and other folks here on the ground aren't sure why. Now, I'm going to pose this question to Amanda. Okay, and now she's thinking, "Oh no, you asked me a question." Yes, I'm going to ask you a question, and there's not a right or wrong answer actually, because you'll probably get it right, I would think. You have this reflective array on the moon, Amanda, and you have a laser going to it, and the light's going to bounce off and come back to the Earth. What types of things on this moon can cause the light to be reflected less back from the moon? What do you think could cause that?
I have guesses, but I'm so...
No, go for it.
I want to say atmosphere. That might not be the right word, though.
Well, you're on the right track, but it's the wrong not exactly atmosphere, but keep going. You're on the right track. Keep going. What again? Something
like debris, particles, like.
She got it exactly. Particles.
Yeah, okay.
Yeah, very good. And what's funny is, okay, Amanda's not a lunar geologist. Amanda's not a lunar scientist. Okay, she could be, all right, but she's not yet. However, she could reason out what might be wrong with these retroreflectors. And when I heard the problem, I immediately thought the same thing. All right, so we thought the same thing, Amanda. And one of the things it could be is that when you have a body like the moon, it's always attracting micrometeorites, and some big ones, as we saw in SkyTour livestream last January of 2020, when the lunar eclipse was occurring. At the height of the eclipse, it was us and 5 other groups on the planet that caught the meteor that actually struck the moon. We saw it hit, and it flashed. Do you remember that? We were just one of 5 groups to see it in the whole world.
I don't think I was on that stream, but I remember how excited everyone was.
Oh,
when
yeah.
we caught it.
Yeah.
I think, Daryl, you were on that stream, weren't you?
I was. I remember it well. That was 2019, wasn't it, Mark?
Maybe you're right. It was January, though. Was it January? Well, no, January 2020, wasn't it? The beginning of 2020?
I thought it was last year.
Okay, you can be right.
Yeah, could be wrong, too.
2020 has been a very long year.
It has.
This is true.
A lot of things have gone on in 2020. But the bottom line here is that the moon's always getting hit by things, and there's no atmosphere to slow them down, and there's plenty of dust to get, up and blast it off the lunar surface. It'd go long distances before it comes back down to the ground. So over time, it's possible that the moon has been somewhat shrouded in its own debris, its own dust, as you mentioned earlier, Amanda. And so it's possible now that these retroreflectors have been covered with so much dust that they're now reflecting a lot less light. Keep in mind that these little tiny particles of dust are like glass. And so when the light hits them, a couple things can happen. The light could be refracted and reflected in many different directions, besides the one going back toward the person who sent the green laser pulse. Or the light could just be absorbed by a dust particle that's dark or something on the retroreflector. Either way, it adds up to only 10% of the return echo getting back. So what they did instead was they did something different. They used the Lunar Reconnaissance Orbiter, which is the orbiter that makes this tremendous swaths of the moon in very, very high resolution photos. And we talk about the Lunar Reconnaissance Orbiter QuickMap. That's QuickMap, one word, and look it up. And you can explore the moon down to just 10 to 15 feet. All right, because it goes down to such small sizes. You can see all the tracks from the Apollo astronauts and the rovers, and in some cases even the flags. They're tiny little pixel-sized things, but still you can see them. And so what they did was they said, we're going to take this Lunar Reconnaissance Orbiter and we're going to spin it so that its reflector array that we put on it can be seen. And we're going to try and hit that reflector array from Earth on this orbiting satellite. All right. It's going to hit something the size of basically a library book, a small paperback novel, I should say. Okay. And that object, that reflector, would be reflecting back the laser light. And that would give us, based on its return, that would give us the distance to the moon. And they actually tried it for quite a bit of time. Because remember, it's a tiny object, 240,000 miles away, and it's moving at a high speed, in orbit around the moon. Well, they did it. They hit it, and they were able to get their measurements. So that is a way, you see, that cross-engineering has actually helped us out of a problem. Just in the same way that when the Kepler Space Telescope went silent for a while because of the fact that its reaction wheels, the things that drive it and move it and hold it on stars very, very accurately, stopped working. There were 4. It could run on 3. and it lost one more. So it lost two. So it was down to two reaction wheels. Well, they had to re-engineer how Kepler worked in order to use the pressure of the sun's light on Kepler Space Telescope in order to then point it accurately again. And that worked until the final little bits of fuel that were left on the Kepler were exhausted. And then, well, that was it. Then Kepler was finally defunct. Actually, it was called the K2 mission when they re-engineered it. So, that said, on the moon, the Lunar Reconnaissance Orbiter was used in a way that it wasn't intended. They actually spun it, and they made it face the Earth, and they were able to hit that little reflector, again, the size of a little paperback novel, from 240,000 miles away. Now, if that isn't an achievement, I don't know what is. Okay? That's a moving target. Now, you know, if there was a sniper shot, that would have been the most accurate sniper shot in the universe, as far as we know. Okay?
What a game of billiards.
Yeah, right. That's exactly right, because it was moving on top of it. That's right. So, anyway, so that's what they did to figure that out. Now, as far as the retroreflector experiment, don't know what the future is. If we have another moon landing there, where maybe we'll actually go to that reflector with a paintbrush and just brush it off, you know, and then it can be used again. Or we'll do is put up a new one. Either way. So next in our astronauts to talk about tonight is the fact that SpaceX has launched 57 more satellites. But this time they're called the visor sats because they have these sunshades on them. Now, these are in response to Elon Musk trying to respond to our astronomical requirements that the sky remain dark for doing professional astronomy. And so it's something that will help minimize these brightly lit objects that are the targets of astronomical ire. Well, I looked at these, and you know what? It's still going to be a problem because the visor sat is actually a fold-out contraption that will actually make the profile of the satellite even bigger in orbit. So yes, whereas it's going to block the bright sunlight from striking the satellite, it's not going to block the bright sunlight from striking the visor and reflecting back. Yes, there'll be reflection. The reflection will be less. However, there's going to be more of it. It'll be more dim reflection. So overall, we're still going to have the problem. And painting a satellite black is not going to solve the problem either, because black satellites or white satellites, they're still going to reflect a substantial amount of light, believe it or not. So we'll see what happens with that. We'll see how far that goes. We'll see what happens with the night sky as well. Daryl, I don't know. You mentioned, did you tell me you went to try and look for a Starlink train of satellites at one point?
Oh, yeah. It was a thing a while back. It probably still is with people. I managed to catch several of them. I only saw a couple that were really impressive. I mean, you know, they were bright enough to be quite noticeable, and they were like clockwork. About every few seconds, another one would pop up and head off in the same trajectory as the others, so it made like a big train of them across the sky. It was interesting to see, you know, just for the novelty of it, but you know, I don't want this to happen. I don't want there to be tens of thousands of these things up there, you know, lighting up the whole sky and messing it up for us. And I have to say, I heard that one of the earlier iterations of the shield or whatever they were trying to put on one did not work well at all.
Yeah.
Maybe these will be better.
Yeah, well, it's the visor set. It's controversial, but hey, we'll see what happens, you know. We will see what happens. And then, well, last on our list is, well, the famous Arecibo telescope in Puerto Rico has been damaged and taken offline. A cable snapped on the system. And this cable brought down some equipment onto the dish, and it made 3 separate massive holes amounting to about 100 feet in length overall. And it didn't destroy the telescope, which was built in 1960, incidentally. But it was a 3-inch cable that snapped and then flopped around. It damaged some of the equipment up at the top because it has a horn, basically, that listens to the signals captured by the telescope's big, giant dish. It's over 1,000 feet across. But we also have to keep in mind that the telescope was built into a natural hollow. Okay, and that natural hollow was actually called a sinkhole. A karst, K-A-R-S-T, a karst process caused this sinkhole. And a karst processes are topographic, or they yield these topographic landforms that result from the chemical dissolution of carbonate rocks. Okay, so when you have water with different chemicals laden in it passing through carbonate rocks, it will dissolve the rocks, and so that creates a sinkhole. And we have those all over the world. But in this particular case, the karst sinkhole was a perfect spot to put this beautiful inside this beautiful. It's a perfect size to put this beautiful dish. So it was made in this natural hollow. And it's been going since 1960 and finding wonderful things, telling us all kinds of stuff about the universe. And it was originally not meant to do what it was doing, but it ended up becoming a radio telescope, kind of because they found that there's other telescopes that could do the job it was originally designed to do better, and they were much smaller. But this telescope here has managed to view things in the radio spectrum that we just never knew were out there, and we'll talk about those in another episode because I want to save some of that for later. But I don't know if either you, Daryl, or you, Amanda, would like to mention anything about Arecibo. I don't know if you knew about this or if you wanted to talk about it, but go ahead. This is your chance to shine.
Amanda?
The only things I could add are things that Daryl told me about earlier when we talked about this. Daryl, do you want to do the honors, or do you mind me blatantly stealing from you?
No, go ahead.
Apparently, yeah, it just reopened because it was hurt by another storm about 2 years previous, and China took this as an example for one of their observatories.
Yeah, China built a sort of a super Arecibo. They found a similar sort of landform, a bowl-shaped depression, and they built sort of a copy of Arecibo, but it's even bigger than Arecibo, I believe. The one thing I think they should be glad of is the central structure of what you might have called the horn. I guess is still hanging. I thought the thing fell, which probably would have destroyed the entire observatory.
Yeah, I mean it was there. It's still there. They have redundancy built in, but you know what? If a cable goes, and this cable was really weird. Okay, if you think about it, it's not just locked in with nuts and bolts and tightened down on braided cable. I mean, yes, that's part of it. But you know what they did? They actually did more than that. They did all that, and then they encased it in another sleeve and filled that sleeve with another molten metal to actually seal it within that. Yet that all pulled out. And that's why they called it a mysterious damage, because it just didn't make sense that this piece could break out like it did. Because since when does molten metal break apart like that? It just, it wasn't molten anymore. Obviously, it had cooled, but they sealed everything up in this region of the telescope, and it still broke out. Really, I couldn't understand it. But something, it was mysterious. But Arecibo will be down for a little while, but it won't be out because it's really, quite an amazing location. I was in Puerto Rico. I wanted to go to Arecibo, and I just couldn't get to it. Actually, the weather prevented me from going. So I had to basically just hang around elsewhere and couldn't get to Arecibo, unfortunately. But it was a good attempt. We'll do it again. I'm sure, because I would like to go to Arecibo.
Galaxy was wondering, didn't Carl Sagan send his message from Arecibo? Did you mention that?
That's right. I did not mention that, but actually that's become one of the most ubiquitous messages ever seen that was sent from Arecibo. That's correct. And we'll have more on that, by the way, when we come back, because we are approaching our first hard break. But we'll be back to talk about that and take more of your questions. I thought I saw a few zip by in the...
Yes.
Okay. Well,
very active tonight. Thank you, guys.
When we get back, we'll talk about those. This is Mark D'Antonio with SkyTour Radio with Amanda Curran and Daryl Mason. We are your team, and we are going to do this all for you for another hour and a half. We'll be right back.
Hello, this is Commander Cobra of Task Force Griffin, KGR Radio, KGRradio.com. And I need you to be a member like myself of the People's Mosquito and help rebuild and fly this great aircraft. I have 3 friends here today also who are going to ask you the same thing. Consider becoming a member of the People's Mosquito.
Hello, I'm John Lilly. I'm the Managing Director of the People's Mosquito, and I'd like you to donate or support our flying program.
Hi, I'm Ross Sharp. I'm the Director of Engineering of the People's Mosquito, and I'd like you to help us rebuild this magnificent aircraft.
Hi, I'm Bill Ramsey. I'm the Operations Director and Tame Pilot of the People's Mosquito. I need you to join us and become my wingman.
Join all of us and be a supporter of the People's Mosquito program. Thanks.
Hey, Dr. Phil here. I help people solve difficult and trying personal problems every day on my TV show, but there's one problem that's just got me stumped: childhood hunger. Nearly 16 million children in America struggle with it. That's 1 in 5 kids who may not know where their next meal is coming from, despite the fact that there's more than enough healthy, nutritious food out there to feed them all. Now, I don't know about you, but that is unacceptable to me. Luckily, the Feeding America network of good people is out there collecting surplus food and giving hope to hungry children and their families at local food banks all across the country. But let's face it, they can't do it without your help. Join me in supporting Feeding America and your local food bank at feedingamerica.org.
Brought to you by Feeding America and the Ad Council. Together, we can solve hunger. Together, we're feeding America.
Folks, this is very important information. What's to be said about CBD? AncientLifeOil.com. Our CBD is made from hemp and has 0.003 THC, which means this wonderful product won't get you high, no matter what amount you take. What does CBD do for the body? My hands are tied. But you can Google CBD benefits and be astounded. When you're finished reading, you'll want to log on to AncientLifeOil.com. That's AncientLifeOil.com. and purchase. Life is good when you feel good. People are tired of pain. People are asking for non-GMO organic products to help them with, you fill in the blank. Legal in 49 states, and again, our CBD is made from hemp. Ancient Life Oil is about helping people one by one by one. If you wonder how good the product is, the CEO takes it every day without miss. AncientLifeOil.com. That's AncientLifeOil.com. Have a great day.
Now you have the inside contact for Alternative Talk Radio. The Planet. KGRARadio.com.
Hey, welcome back to SkyTour Radio. I think that's what we are, right, Amanda? SkyTour Radio?
Quite possibly.
Very possibly, yes. And this is Mark D'Antonio with Amanda Curran and Daryl Mason, your all-star triplet of astronomical prowess, waiting to answer your every question. How's that sound? You don't have to pay me now, Daryl. You can pay me later for that.
Well, I'm the black sheep of the family anyway, so.
Yeah, as if. So, when we talk about all these things, it inevitably brings up questions. So, Amanda, if you got some questions from the chat, I'd love to answer now before we head into Star System 101, which is our feature tonight. But
well, right now, I know you were going to get back to Carl Sagan's message from Arecibo, and Charles was good enough to put up some pictures. Well, I don't know if that's the right terminology, but I've seen these before. I don't know how to describe them. Like a little person and a little. There's like it's all dots. It's all pixels.
Yeah, that was the message that was 1974, I think. It was carrying the basic information about Earth and all of us, and it was actually aimed at a particular location in the heavens. Do you know where it was aimed, Amanda?
I may know.
You may know too, Daryl. Yes, but do you know where, Amanda? You
Andromeda?
That would have been a better choice, maybe, but that's 2 million light years away.
Oh.
Actually, Daryl probably knows. Go ahead, Daryl.
It was M13 globular cluster, wasn't it?
It was. It was indeed.
Yeah. And
Yeah.
what the heck? I mean, that's so far away anyway. What, 13,000 light years or something?
At least, but still.
What was the significance of that?
Well, it's a cluster with 40 to 50,000 or more stars in it, and back then in '74 we didn't know much about the potential for life in globular clusters, but we thought, hey, globular cluster, lots of stars, potentially stars like the sun, maybe there could be life there. Well, as it turns out, in our later understanding, we find out that the stars within a globular cluster generally don't have a lot of heavier elements in them, meaning that there's probably a dearth or lack of heavy elements from which, things like planets are made. So it might be that there's not a whole lot of planets in globular clusters. In fact, we've only seen a handful of potential planets in globular clusters. So that might have been a mistaken send. We probably should have sent it toward the center of the Milky Way, if we could, but maybe the globular cluster M13 happened to be transiting over Arecibo, and maybe we couldn't send to the center of the galaxy, perhaps. I'm not sure, but it would have been great if we could. And that was the Arecibo message, which everybody here's heard about. It's the SETI Institute that I think did that. It was broadcast deliberately, and it was part of the push for the hunt for extraterrestrial life. I believe that one of my favorite astronomers, Carl Sagan, had engaged in over the years, because as he had said, we are a pale blue dot in the heavens. And that's his, tagline, we're a pale blue dot. So I think that we were probably ahead of the curve in trying to contact potential extraterrestrial civilizations. But if you think about it, the message only consisted of 1,679 little bits of information. And that was it, and it was meant to try and, celebrate our place in the heavens and tell people where we are and where we're from. And it basically talked about our solar system. It talked about, it showed basically, first of all, the basic elements of life. Then it showed the basic chemistry of life, nucleotides in particular. And these nucleotides were all ones that we know about within DNA, thymine and all these other kinds of the nucleotides, cytosine and all those things, guanine and so forth. And then we have the shape of DNA shown in there. We have the shape of humans with the height as well. The population of the world at the time, which was 4.3 billion, by the way, in 1974, that's when this was sent. Our position in the solar system with the sun and the position of the planets came next. And then we had the transmitter itself. The Arecibo telescope was represented in this message as well. So it was really kind of a cool message. It was a very simple message, but if it could be decoded, they would probably notice the human form if they saw, hey, that looks like a form of life like we have here. Because I imagine that the bipedalism, that is the walking upright instead of on all fours, I imagine that the bilateral symmetry, same on the left as on the right, basically, I think something like that would actually be a very important thing to convey to an extraterrestrial species, because then that would mean that most likely, based on the nucleotides we're trying to show them, that maybe they didn't figure out yet, maybe they could figure that we're carbon-based. And if then they go back up top and they could say, are they trying to tell us about hydrogen, carbon, nitrogen, oxygen, and phosphorus? Because that's what this looks like they're trying to do, and that makes sense, and they could take it from there. And then the basic chemistry of these nucleotides is something that would actually also make it really neat, for understanding. I think that's a really cool, I think it was a really cool message. I just wish that, I really, really wish that we got an answer, but we didn't.
It was basically like a 2-bit image, wasn't it?
Yeah, it was
sort of a Pong of interstellar imagery.
That's right. The Pong of interstellar. That's a very good point. A good way to put it. Yeah, and it was, like I said, it's over just over 1,600 bits of information. Where a 0 is off, a 1 is on, basically. And it was really kind of cool. But I think that including the basic chemistry of life, well, if they could understand that, they would see that we're carbon-based. And the DNA helix, the double helix, is represented there above the humans. I mean, it was actually kind of, if you think about it, a real clever message. Quite a clever message. But yeah, so
we have a few follow-ups on that, actually. A few people are mentioning it was either duplicated or we received a response as a crop circle. I don't know if you guys know anything about that or not. And Charles is asking if our scientists were ever able to decipher it. He said that, I guess, when they wanted to send the signal out, they tried it on Earth scientists to see if they could decipher it.
Yeah.
Did they? Do we know the outcome on that?
I do not. Daryl, do you?
Sorry, no, I don't.
See, I thought it was all supposed to be based on basic math that would be kind of universally understood. Well, I say universally, no pun intended. No matter what kind of country or culture, scientists would still understand the math on Earth. So that is kind of, I thought this is very vague for me, but how could we not know if we were able to crack it too? Did Sagan just make it up?
Wasn't there some sort of a key involved, Mark, that tried to express what the size of the image would have been, for however many bits they sent, to break it down, 1,600 by 1,000 or whatever?
Yeah, oh man, that's really testing my memory, Daryl. And you know me, I'm not going to say something I don't know. I'd have to get back to you on that. I don't remember actually if there was a key. Because
I didn't. This didn't seem familiar until Charles posted the pictures. I'm like, oh, I've seen that before. I know what this is.
Yeah.
Yeah.
Well, you've seen it on actually record albums too. People, in music, they've used the message as a in the backgrounds of record albums as well as others, as well as other astronomical findings like that too. So a lot of really cool stuff, But I'm not sure. I'm not sure if there was a key, Daryl. I don't remember that.
That sounds familiar to me too.
Yeah. Well, for however long the string of bits was, I think they'd, to help people along, there would have been some kind of clue that would have helped whoever the receiver was figure out, how to break it down, like a length by width or whatever. Know what I mean?
I do, and that could have been as simple as one different tone every line, the same tone at the end of every line kind of a thing. It would be like a carriage return, right? Going to the next line. Something like that, maybe. I mean, that's how I would do a linear message if I had to. I would go like bing, 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 like that, and just all the way down. And all the bings would be the end of the line. And, logically thinking beings like us might think about that, but who knows? We don't know how other beings think, and we can't project human reactions and human methodologies onto an alien life form that we don't even know of. We don't know how they think, but it could be that.
Did either of you guys hear anything about crop circles?
I never heard that.
I think I've seen a little semblance of the crop circle that had come in that somebody had talked about. for me, the jury's out on crop circles. I don't know if they're made by just people playing around or whether they're made by secret military activities, or extraterrestrial entities. When it comes to crop circles, sometimes the simplest explanation is the correct one. But I am certainly open to the fact that to the possibility, I should say, that it's not as simple as even I think. It could be something very complex behind there. I'm not sure. I've never heard of crop circle.
I could well imagine some enterprising person taking the image we sent from Arecibo and making a crop circle with it.
Yeah.
I would be interested in the year the crop circle was found. Because, how would just the average person have access to these images?
Images are out there. They've been out there for a long time.
Well, yeah, but not in the 70s.
No, they were published in books, though, Amanda. You got to remember.
Oh, yeah?
Yeah.
Oh.
We had books with all kinds of photos, so they could have, and that's kind of funny, isn't it? Because people think only the internet wasn't around, so how could they possibly have seen these photos?
No, I thought it would be a little more high class and something you could check out at your local library. That's all.
I know, but it wasn't.
Military stuff, sending things to other planets, trying to make contact. Yeah, I didn't think that would be accessible to the public. That's cool. That's awesome.
Yeah, that wasn't a military operation. It was actually a civilian operation. And the interesting thing is that when it happened, I was I was a kid basically, still in junior high maybe. I don't remember. I found that was quite a wonderful time. I thought, wow, man, we sent a message to the stars, because it was out there published and people stated and talked about it. The news had it on there. They showed an image of it on the news, on the TV. So they said, this is what was sent out to the, it was like, Walter Cronkite, this message has been sent to someone out there in the universe. That's how he talked. It was really kind of cool. I was just eating it up like, wow, we sent a message to someone who may or may not ever hear it.
I could very well imagine. Mark, you mentioned Occam's razor earlier, the simplest solution, most likely solution and all that. If there was a crop circle that looked like the message we sent, well, was it made by aliens or made by some prankster here on Earth? I think Occam's razor would say the prankster did it.
Yeah. As the Mutual UFO Network's chief photo and video analyst, I often find that Occam's razor comes into play, not because it's just used as a catch-all excuse, but because the technology displayed, the information provided, the evidence seen, all indicates something that it could also be. And if it could be aliens that did this, and it could also have been humans, then we can't say it was aliens. We have to err on the side of saying that it was likely human, but maybe there's a very slim chance that it was actually extraterrestrial, but it's very likely human made. And so we do that because obviously we must, as researchers and folks that analyze these things, we have to basically say we must err on the side that will allow people that come after us to know that we did our diligence, all due diligence, to find out whether what we're seeing here is something that was actually human made or alien. If we say it's alien, then we have to be 100% certain. We can't say with 90% certainty that it's alien. We can't even say that it's alien with 99% certainty. Because in our view, if it really came from some extraterrestrial influence, then we think there would be 100% certainty, because there'd be a 100% evidence that it did. And it would be something that absolutely could not have ever been created here on this planet. And that's the tactic I take. And people will say, oh, well, you'll never get any UFOs that way. Well, you know what? That's not true. you will, because if you do your diligence and you do the right work and you do the research properly and the analysis exquisitely, then you should be able to deduce whether this is something that could be created on Earth by people, by pranksters, by a computer, by accident, by some extraordinary capturing of an ordinary object. I mean, so there has to be a way that you can quantify that. And so that's what MUFON does. We try to quantify these things in this way. And so, yeah, we may not say everything's a UFO, but if we do, I can guarantee you that thing is certainly something we've never seen before. So we're looking for that. And that's what science is. Science is lots of misses, and very, very, very occasional hits. And that's what it's all about. You don't get tired of it. You just keep plodding along. So that's kind of what it's all about. I know that's kind of a little different, but I'm trying to say that to go with your Occam's razor comment there, Daryl, that maybe, Occam's razor says the simplest explanation is probably the most likely kind of a thing. And if there is something that seems likely, then we do have to err on the cautious side, saying that, well, it could be that. It's likely that. So anyway, I know people disagree with me on that, but I have to be really hard on the data. Otherwise, someone who comes after me will say, why didn't you think of this thing? What about that? It could have been this. And I want to be able to say, yeah, we know it's not that. We know it's not that. Or we do know it's this. That kind of thing. We have to have that information. So anyway, that's where we go. I'm sorry, Amanda. I think there were more questions, too, that you wanted to throw out.
There were. Let me see. I was going to say, actually, speaking of things that, possible reasons on why something's happening, we had a few questions on Betelgeuse. Kathy wanted to know if you were going to talk about Betelgeuse. We think we might know why it's dimming now. We have a pretty good theory. And Dobbs also said that they read that Betelgeuse is predicted to go supernova astronomically soon, they say. Does the discovery of the dust cloud discount that possibility? So maybe we could touch on both of them before the break.
Yeah, that's really good because Emma, thank you for that question. That was Kathy, right?
Kathy was one, and Dobb was the other.
Okay, Kathy and Dobb, thank you for those questions. That was actually really good questions. And we refuse to answer them categorically. No, I'm kidding. The truth is, Betelgeuse, we noticed that dimming, as you all know. And we knew previously that Betelgeuse, being a red giant near the end of its life, had only a limited time left. And we're seeing that Betelgeuse is getting dim. Now, if it was going to go into what's called a core collapse supernova, where it goes and the core stops fusing and the gravity, the force of gravity wins and just comes down and smashes into the core and then blows outward. If that were to happen, then different things would have happened. It wouldn't have just got gradually dimmer. The gradual dimming from the very beginning was something that I thought could be some dust being expelled from the star, a dust mask being thrown up by the star originally, and there was no evidence of it. So I was basically just kind of yelling at the wind. Basically, there was nobody to hear that, because there wasn't any research to show it at that point, and they were just as good a theory as any. And there were other theories that maybe Betelgeuse was actually shrinking and getting smaller. At one point, I thought maybe it was doing that. But we didn't see the subsequent change in its output energy. When it gets smaller, okay, it should get hotter in the core, and we should see new things start to fuse, and we should start to see a brightening, actually. It didn't change. It was acting as if the star itself wasn't involved. That's the key point here. The dimming was acting like the star itself wasn't involved. It's like somebody's putting a veil in front of Betelgeuse. So when astronomers started going down that path and they started to look at research, they realized, well, Betelgeuse, being a red giant, is huge. I mean, if you put it where our solar system's sun is, it would go out past the orbit of Mars, almost to Jupiter. And so that size, that far out, the outer fringe atmosphere of Betelgeuse is gravitationally bound to the center of the star, to to the gravitational force of the star, but it's not. It's just sort of on the edge at that point, and an outward pressure from a flare or some other expulsion of energy from the star would easily push that stuff away, and it wouldn't have any compelled. It wouldn't be compelled to come back by anything. The outward pressure would be enough to let it go free of the star. So basically, at the outer edge, these types of shells would get expelled from the star over time. And over time, those build up into something we call a planetary nebula for a star that's smaller, that goes to a red giant, like our sun will. Or it's a star that will have these shells around it prior to going supernova. And Betelgeuse is more massive by far, and it's going to go supernova. So seeing the shells potentially making these shells, we know it has shells around it already. But seeing more of this material seemed to indicate that, hey, Betelgeuse may very well be doing its last death throes here, possibly. Maybe this is what happens. We have no information about this, so we didn't know. So speculation was rampant, and we were all wondering what we were going to expect. So, next.
May I add something to that?
You may.
Betelgeuse has started brightening again. It has been for a while, and it's coming back to normal, which also supports the dark cloud theory.
That's right.
I mean, it started brightening again, last fall, something like that.
Yeah. Now,
so it's getting back to where it was.
Now, what is that dark cloud? Let's think about that. Now, the dark cloud is going to have to be something that would obscure the energy behind it. So that dark cloud must be something that's a tangible matter, right? You can't have a dark gas, right? So if it was just gas coming off, then it wouldn't be dark, but it might, it could technically mix with the light and cause the light to be dimmed because it's absorbing energy from behind, all right? But we'd see that. So what's happening?
My guess is your favorite element.
You think so?
Yes.
Daryl's going to say carbon.
Daryl doesn't need to say carbon, I think.
Well, it's possible, but there's no.
Well, I've heard it described of as soot.
Yes, yeah, and carbon stars are really, really just garnet red. They're just beautiful. And Skytour Livestream, I actually looked up carbon stars. We're going to actually look at some the next clear night. There's several available to us. When you see a carbon star, it looks very different from any other star you've seen. Oh, we've seen orange stars. We've seen blue stars and so forth, and white stars and blue. But you haven't really seen a star until you've seen a carbon star. These are so dark red. They're just phenomenal. They're captivating. So anyway, Betelgeuse, although not a carbon star per se, might be developing molecules in its outer distended atmosphere where it's cooler way, way, way out there. Okay. And if it does so, then maybe it's developing this sooty material. That sooty material could indeed block the light. And if there was an explosion off of Betelgeuse, a flare of this material that pushed a lot of this material off the star, then perhaps it pushed off in our direction. And as this material cooled and these molecules formed, maybe they actually created this sooty blocker to the star's light and caused the dimming. Now, we don't know. Betelgeuse, however, is one of the few stars that we can actually see the round shape of, the round disk of in the sky. Okay? Not with any telescope we have in Skytour Livestream, not with any telescope here on Earth, except for some of the ones that have something called an optical system that allows them to actually see this. Okay? And that particular adaptive optics system is what's required to actually see this. It's called an interferometer as well. They can do it through that. And these systems can resolve the disk of a very, very big star like Betelgeuse, and I think they've done Antares as well, the Eye of the Scorpion and Scorpius. So these are some really interesting findings with Betelgeuse, and we might talk about a little bit more about Betelgeuse in the next segment here as we go. But we do have much to cover tonight. But you know what? If you guys have questions, I will continue with questions until we get through it, because I would like you to have your questions answered first and foremost. So why don't you stick around, hang with us, and when we get back on the other side of this break, we will join this Earth already in motion. All right? So we'll be back right after these words, folks. This is Sky Tour Radio.
Hi, folks. It's troubling times, and fear is pushing emotions, which in turn pushes health the wrong direction. Do you ever get an ache because life is uneasy? Try Life Change Tea at getthetea.com. Life Change Tea works on your digestive tract, helping to move food through quicker and comfortably so your health is spot on. Life Change Tea may not help with world issues, but it will help with your digestive issues. A glass a day helps keep the intruders away. So, change your life today. Log on to getthetea.com. That's getthetea.com. If your health game is off, get on by ordering Life Change Tea. Getthetea.com. And while you're on our site, look around at the great non-GMO organic supplements. And if you're a sales shopper, go to our specials page and see what's for you. I've been drinking the tea for 12 years, and I'm sure glad for its health benefits. Again, that's getthetea.com. Getthetea.com. The tea that makes you go. Please listen. Now is not the time to fear. When your immune system is strong, shields up. You have very little worries. If your immune system is compromised, you're susceptible to all viruses. I say shields up and no fear. Try Heart Love from getthetea.com. Heart Love has a special ingredient called allicin. It comes from the healing part of the garlic plant. No garlic breath. No garlic leaking out your pores, just pure immune-building ingredients that gets your shields up. Heart Love is a unique blend of herbs that loves to build you up. Google garlic and know the benefits. One Heart Love pill is equal to 20 cloves of garlic. 20 cloves! Shields up. You've heard of our Life Change Cleansing Tea at getthetea.com. Now try Heart Love. And by the way, take your blood pressure and watch weekly what happens. So here's how to purchase. Log on to getthetea.com. That's getthetea.com and build your shields. That's getthetea.com. Mention Ray in the coupon code and hit apply and receive free shipping.
Permanent industrial glue impossible to remove? Not anymore. Because Handyman Formula by D-Bond is a patented chemical adhesive remover. It's used in the building and home maintenance industry, but now it's available for your home use, for your DIY projects. Unglue stickers, silicone rubber, labels, price tags, flex tape, weather stripping, carpet glue, wood glue, liquid nails, even 3M 5200. And it dissolves graffiti. Yeah, graffiti. Handyman Formula by D-Bond works, and it's safe to use on most surfaces. No need to call a professional. Don't get out the pliers and blowtorch. Just apply a little Handyman Formula by D-Bond and wait 90 seconds, then quickly and easily pull the items apart. Get unstuck. Visit DBondHandymanFormula.com. That's DBondHandymanFormula.com or call 561-575-4200. Handyman Formula by D-Bond.
You listen to us, and we listen to you. And so does the CIA. KGRARadio.com.
Hey, we're back. Do you know that? We're back. This is Sky Tour Radio, and it's Sunday night. It's 9 o'clock. And you know what? We have way more than an hour's worth of material left, but we also have a lot of questions left too. And I did want to turn it right back over to our wonderful dear Amanda, who is so good about grabbing questions. You know, just make sure you let her know what you think of her, okay? She's really, really good at this. I know Daryl and I really appreciate her. So Amanda, go right ahead and tell us what else you got for us.
Oh, we have a bit of everything here. Actually, I'm not sure if you guys are aware on this. I don't want to throw something at you guys haven't read about. But John wanted to know if one of the stories we were going to touch on tonight was the use of lava tubes on either the moon or Mars for habitation. Do you guys know about that?
Yes, actually. One of the problems we have going to the moon, we'll talk about the moon because it's really the moon that this originated with. We've seen lava tubes on Mars. Actually, it's one of the craters on Mars. The bottom seems like it's open, and of course the conspiracy guys have gone nuts with that, saying it's a nuclear site. It's a silo. Yeah, just happens to be shaped like a crater that's weathered for 24 million years. But the moon has lava tubes. And what's a lava tube? Well, just like here on Earth, in Hawaii in particular, you can actually see an area where a large conduit of lava moved underground. And as it's moving underground, the walls that it's moving in initially were going to be a little bit cooler as it's moving through this rock and creating this tube. Well, that would cause the lava to cool and form a shell within which the hotter lava could go through, and that shell around the outside would act as an insulator basically for the heat of that lava in the middle. And so that lava would continue through until it then drained and was done. And it would leave this long tube that was basically a shell all the way around of lava, a long tube you could walk through. In fact, people walk through lava tubes. They can be huge in diameter, way bigger than you. You know, they're not little tiny things. These could be massive, massive tubes. And so this happened on the moon as well, the same kind of process. And these lava tubes will go under the ground for quite some distance and could be fairly deep under the ground. Now, on the moon, that would make a lot of sense for astronauts. And why? Because one of the problems we have on the moon is solar radiation. And I don't mean from heat, that's one thing, but actually deadly radiation, ultraviolet radiation. Well, it doesn't penetrate deeply into the lunar crust, okay? So we would need to have a protected environment within which to have a lunar habitat of some kind. And this lunar habitat could easily be within a lava tube where we already have a structure around us, and all we have to do is inflate a big habitat inside a lava tube. And we already have a protection around us, and we just have to have the habitat with the oxygen and so forth inside. All right. And once we get to the moon, we would actually do things like make our own oxygen. Now, there's another story that our darling Amanda sent to me that was beautiful. It had to do with the MOXIE instrument, which was the Mars oxygen in situ experiment on Mars. And it was one that would actually take the carbon dioxide of Mars atmosphere, and it would actually work like a plant and take in the carbon dioxide and give off oxygen. Now, the process on Mars would have been where they used the carbon dioxide atmosphere to create this oxygen. But on the moon, they would have to do it chemically using compounds in the soils and disassemble compounds in the soils, probably with heat, to generate byproducts, some of which would be noxious and toxic, and leave the oxygen behind that they could use for breathing and for, equally importantly, rocket fuel. Rocket fuel is made with oxygen, so they have to have oxygen generated. On Mars, that won't be a problem if the MOXIE experiment works on the Perseverance rover that's on its way to get there in February. But so we'll see what happens. But, you know, when you take carbon dioxide, for instance, on Mars, and you take in the carbon dioxide and you end up resulting in carbon monoxide, which is CO, and then you can get O2 from two carbon dioxides plus the CO would bind up the carbons and one oxygen, and then you'd get O2, which would be used for rocket fuel and or breathing. So we'd have to make our own. On the moon, like I said, we have to do it chemically, geologically, using the lunar crust and the lunar soils to do that. But the lava tubes would be the place from within to do it, from within which to do it, because they would give us the shielding we need, the radiation shield we need, and they would give us a place to set up a habitat. So I can actually imagine at some point having a habitat on the moon where we inflate a gigantic building inside the lava tube. But first we would have to go in and basically smooth the walls, because lava tubes tend to have craggy edges if they aren't weathered. And inside the lunar surface, down below, there may not be a lot of things to weather those. On the surface of the moon, you get to the moon, and remember in the 50s you saw images of the moon that had big, tall, rocky cliffs and big, giant pinnacles, and you get to the moon and it's all rounded. There's none of that going on the moon. Even in the biggest craters, it's actually more rounded than anything else. That's because of all the impacts and micrometeorite impacts that ended up smoothing off the moon, basically, and all the debris that gets thrown up into the area around the moon called the exosphere, not atmosphere. And it goes up into the exosphere and lands back on the moon. All that stuff would tend to soften features along with the weathering by radiation. But underneath the moon's surface, most of these lava tubes are probably going to retain the sharp nature that they might have had when they formed. So the first thing you'd have to do is go in there and, like with a router, and just route them all out, get rid of all the sharp edges. I would imagine we could do that robotically and make a platform on which to build an inflatable habitat. And then we would inflate the habitat inside the moon, inside a lava tube, and maybe it goes all the way to the outside edges of the lava tube once it's all smooth. And then we'd be fine. I think it'd be pretty cool. So that's kind of one of the things that NASA is looking to do. And if we go to the Martian surface, we have the same problem. Now, it's farther away from the sun, so it's less ultraviolet radiation, but still more than enough to disrupt your DNA and cause cancers and all kinds of things, because the Martian atmosphere has a pressure of 6 millibars. And that means, well, I'll just tell you, on our Earth at sea level, our pressure is over 1,000 millibars. So 6 millibars might as well be a vacuum to humans. It's not a vacuum, really, but to humans it is a vacuum. We could never survive in that. So we would have to actually do something about that. So, but on the moon, we don't have any atmosphere whatsoever, other than some identified atoms of sodium here and there, and some other atoms floating around the moon that the moon has itself retained over time. So I guess to say the moon doesn't have an atmosphere is really a lie. It does, except that it is far, it's measured by a few atoms every centimeter, cubic centimeter, as opposed to billions of atoms every cubic centimeter. And so it's pretty different, okay? So it is a true vacuum for us. But lava tubes are the way to go. They'll protect us from the radiation, and it is something that we're looking at. Yep. Sorry, Amanda, you got more?
May I add something to what you just said?
Please do.
If people have an interest, the romantic images of the moon having these big, tall, jagged peaks.
Chesley Bonestell.
Chesley Bonestell.
Yeah. Oh, okay. That's your good time. Okay.
Yep. He painted these back 40s, 50s, something like that, I think. And, they just didn't know then, what the true topography of the moon was like.
Yeah.
And he painted these really romanticized pictures of rockets landing on the moon, just like SpaceX lands now, perched up right on their landing feet. And they were surrounded by big, jagged, cool-looking mountains. Great minds think alike, huh?
Yeah.
Chesley Bonestell. And also, it's been so long, but Robert Heinlein, the science fiction author, I don't know if he had the idea of lava tubes so much in mind when he wrote the book, The Moon is a Harsh Mistress, but he did put the lunar colonists living underground for precisely the reasons you said.
Yeah. That's good. I don't remember that, actually, so it's good you mentioned that. Thank you, Daryl. That's cool.
No biggie.
Yeah. Incidentally, one of our listeners has sent me a response to the Arecibo answer that we saw that you asked about, Amanda, about the crop circle.
Okay.
Yeah, and that listener, by the way, was none other than Carol Carl. Who was another wonderful host on KGRA. And she writes, the Arecibo answer, quote unquote, is a hoax by people that created an imprint in a crop field in 2001 near the Chilbolton Radio Telescope in Hampshire, UK, portrayed as the response from an extraterrestrial civilization. The crop circle is a near replica of the Arecibo message. So thank you very much, Carol Carl. Behind the Obsidian Curtain, Friday nights at 7 p.m. Anyway, I believe you're helping on that show too, Amanda, correct?
Which one?
Carol
Carol's?
Yeah.
Not as of yet, but anytime she's ready, we will be ready for StreamYard and streaming to all the social medias out there, so stay tuned.
Fantastic. I think we're going to be doing that too, yes?
Rumors have been swirling.
Yeah, okay. That's good. Yeah. That's good.
Except that means I might have to be on camera, so I don't really like that.
Oh, you can just put up a picture of Gumby or something if you'd rather not be on camera.
Yeah.
I have a Gumby. I can send you my little green Gumby. Once he was a little green ball of clay, remember? Gumby.
Aww.
An Art Cloaky production. I watched it as a kid. Anyway, go ahead. More questions?
Lots more questions, yeah. Dub wants you to speak on how carbon resonates in stars so that stars burn up to the next element during stellar burning.
Well, as far as carbon, okay, we have to look at the periodic table. It's actually quite a elaborate question, Dob. Thank you for asking. There's a lot going on inside stars, and when we talk about stars that reach a certain point in their lives, namely one called the AGB, or the asymptotic giant branch, stars actually have swollen into red giants, and they begin at different points dredging up materials that were formed inside or that are already in their atmosphere from when they were formed. Okay, because not all parts of a star are fusing into and making stellar energy. Yes, the sun's a big bright ball in the sky, but a much, much smaller part of it is the only thing driving all that. Okay, and that's in the core. All right, and massive stars can create different elements. Normally, they go from hydrogen to helium. That's what our sun does. Okay, larger stars than our sun, and some like our sun can go from helium and make some carbon. All right, and there's other processes that perform this nuclear fusion, or the way stars make energy from hydrogen, okay, and helium. There's one's called the CNO cycle, which is carbon, nitrogen, oxygen. It's what's called a catalytic reaction. It makes more energy. It releases a lot of energy to do the fusion. And the other one is the one that our sun uses, which is the predominantly just converting hydrogen into helium, basically. All right. Now, as far as the carbon, what happens, especially when we see stars like carbon stars, there's this dredging that occurs from deep inside the star. And carbon materials somehow make it to the surface of the star. And it makes this soot that we talked about with Betelgeuse a little while ago. And the stars end up going from being red giants to actually very crimson red giants. As I said, when you see these things in a telescope, you're going to say, what? That's a star? I mean, it doesn't even look real, but it is. And so the carbon, once it's on the outside of the star, doesn't have anything to do with nuclear fusion at all. Okay, because the only thing that's doing the fusion is deep in the core. And for some of those stars, that could be many astronomical units away. Okay, because we're talking about a diameter, remember, that could be as big as the orbit of Mars out to Jupiter and beyond. So we're talking about a very, very large star overall. For that case. But if you can see the carbon in the atmosphere, it's not fusing. It has nothing to do with what's going on in the core at all. And if I misunderstood your question about that, Dom, let me know, and I'll go over it again. But we'll move forward here, Amanda, with the next one.
Okay, the next one is Galaxy wants to know, are we able to compress matter in experiments such as what is happening in a neutron star? They said last time you spoke of neutrons being extremely volatile if brought to Earth, and they were to explode and devour our planet or a nearby area. Basically, are we able to knit neutrons as tight as they are on a dead star?
No, I mean, we can't achieve those kinds of pressures. And even in our particle accelerators, we can't generate the kind of pressures that are present in a neutron star. You have to understand, the neutron star, the neutrons are getting compressed so tightly in a neutron star. And by the way, that's even more so than a white dwarf. Okay, in a white dwarf, okay, the atoms are being compressed as well. Actually, the nuclei is all you have left of the atoms, and they're being compressed as well. And what happens is electrons in those stars are forced into these discrete energy levels. Think of them as a checkerboard, all right? And this applies to neutron stars coming up, so hang on. So if you think of a checkerboard with the red and black squares, okay, across the whole board, you put one electron in each square. Okay, that's a quantum state, one energy level. You can't put more than one in a square. So when the whole checkerboard is filled up, then that cannot be compressed any further, all right, because that pressure will be, all the electrons inside will push out with a pressure all their own. And that's called electron degeneracy pressure. All right, it's degenerate matter at that point, as it's called. And this is what actually holds up a white dwarf. And that's a star that's actually less than 1.44 solar masses in the core. All right. Beyond that, and Daryl knows this, he's mentioned it before, beyond that limit called the Chandrasekhar limit, all right, then the collapse can go further beyond white dwarf. Now, what would make it go beyond that? Well, if the star was more massive to begin with, it would go beyond that. Okay. If a white dwarf is acquiring mass from another nearby star in a binary system, then if it's more likely it's going to explode and go supernova, which is a type 1A supernova, as we call it. That would actually cause the white dwarf to explode. But if by chance it could just acquire the material and then just be more than 1.44 solar masses, it would continue to collapse into a neutron star, perhaps. Now, the neutron star, now the neutrons are in this degenerate state where they have their own pressure pushing out and don't allow the star to collapse any further. But once it gets above 2 solar masses in that mass in the core, then they collapse even further into what we call a black hole, right? And that's pretty much the 3 states we know of. Now, a neutron star could be highly magnetic. They are generally anyway, but they could be very, very highly magnetic, in which case they're called magnetars, which is really a cool name. I think that'd be a great name for a villain. It's Magnetar, look out, But magnetars are also, they'd rip you apart. They have so much magnetic energy that you couldn't even come close to them. The very molecules in your body would be torn asunder, just ripped to pieces. What a way to go. Why did I do that? Why did I even say that? But the bottom line is that the neutron degeneracy pressure would keep that star from collapsing any further. Now, we can't generate that kind of pressure here on Earth. And if you brought a teaspoonful of that to the Earth, it would weigh more than 1 billion tons. All right? Just a teaspoon. Wow. I think that is really, really incredible, So it's hard to imagine a teaspoon of anything weighing 1 billion tons. Because if you look at something that does weigh 1 billion tons on the Earth, and you say, wow, what weighs 1 billion tons? And then you realize this comes from something that's only 2 miles across, okay? Just a few kilometers across. I mean, that is amazing, So anyway, I think that I don't know if I ever said they would blow up or anything, but explode. But I think I said that that much mass on the Earth could very well cause another gravitational well on the Earth that could cause problems for sure. And, you wouldn't want to drop it into a hole that goes all the way to the center of the Earth, because then the Earth would suddenly become a lot more massive a little bit. It could cause a problem too. Who knows?
I think I said that about it possibly exploding. The huge mass of the entire star being turned into a ball of solid neutrons, neutronium, a couple of miles across, is what holds it together. And if you were to take a spoonful of neutronium and bring it here to Earth, that mass of gravity would no longer be there to hold it compressed together, and it would explosively decompress.
I see what you're saying. Okay. All right, fair enough. I wasn't even thinking down that side of the path. I was just thinking of, the neutron star and the pressures. But Daryl's correct on that. Okay. Go ahead, Amanda.
Okay. Have either of you guys heard if NASA will be sharing videos of the Mars helicopter that they're going to try?
Oh, yeah.
Surely they will.
They sure are. You're going to see video from the helicopter as well as images of the helicopter in flight from the Perseverance rover. And for those that don't know how that thing works, look up JPL tests Ingenuity helicopter. That's the name of the helicopter, Ingenuity. Or just look up JPL tests Mars helicopter, and you'll watch it run. And it's going to run in an atmosphere about the same pressure. It's a special chamber they ran it in, a special chamber that is set to the Martian air pressure. So 6 millibars, okay? It's like a vacuum chamber, but massive. And what you do is, when you watch this, take a watch and listen. You'll actually hear the helicopter very loudly, because even with 6 millibar pressure, you still hear the sound quite loudly. And the Perseverance rover actually has microphones on it as well. If you recall, one of the things we talked about was it has some very good high-definition microphones to hear the sounds of Mars. You will hear the helicopter in flight as well. I think that's going to be pretty cool.
That's going to be amazing. I thought I had heard that, it was a possibility, but you're saying it's a definite thing. This is definitely going to happen.
Oh, absolutely.
Right on. That's awesome.
From the helicopter and from the rover watching the helicopter.
Yeah. Well,
in high definition, by the way, too, just so you know.
Did you say the rover is going to be following it then?
It's going to be looking at it and watching it fly. So we'll see it flying.
Yeah, but how far away is it going to fly? What if it flies out of view? That's what
then
I mean.
We won't see it.
So the rover won't track it.
The thing is that the helicopter's not designed to actually fly far, far away from the rover. It's going to go more upwards than far away. And the reason is because the rover is the thing that's relaying the commands to the helicopter to do whatever it's going to do. All right. So the rover is actually going to be the little radio controller, basically, for this helicopter. That'd be like the longest distance, the most far away radio-controlled helicopter in the history of humankind. I think that's pretty cool.
That's amazing.
Yeah. So go ahead, Amanda. There's got to be more questions, huh?
There are. It's kind of follow-up to previous questions, and I know we're coming up close to the break, but there's actually something cool I forgot to tell you about. Speaking of Mars, there was a really cool site I heard about during Gish Week, and one of the items was to complete a project. It was called AI for Mars, and you can Google that. It's a site you can go to, and they give you a little tutorial of all the kinds of terrains on Mars and how to identify them. And I don't know if I can remember them all now. I think it was sand, soil, bedrock, and big rock, and what they all meant. And you can actually go and chart. You put up little grids on different little pictures of different terrains on Mars. So it's free. They're not asking for money or information or anything. It's just if you want to volunteer and help out. So it's AI and the number 4 and Mars. And yeah, I think it's training kind of the rovers to eventually be able to interpret this themselves, so they don't, run into anything they can't get around or get stuck in. So it's very, very cool. So I think this is the right crowd to tell about. So AI for Mars. I'll grab the link on commercials.
Wonderful. Thank you, Amanda. And if we come back from commercial, guys, and we're not here, well, you know where we are. We're going to be off playing AI for Mars. AI numeral 4 Mars.
Yeah.
Fantastic.
I can't remember if it's org or .com, or I can't remember. I'll double check, but I'll send the link in the Discord chat. Anyone who wants to join the chat, we are on Discord, KGRA.
All right.
We'll be back after the break.
Fantastic. All right. Well, guys, you know what? we're up against it again. Where does the time go? When we come back, the lines will be open, and we do have more questions. So we will take the rest of your questions as well. This is, after all, Sky Tour Radio, and we love to answer all your questions and talk astronomy all day, all night, all the time. And please go out to Sky Tour live stream and do subscribe, will you? I mean, over 4,300 people so far. Can't be wrong. So come on, join us. You'll see Amanda, you'll see Daryl, you'll see me, and we will actually be seeing the deep sky. We'll be right back after these words. This is Sky Tour Radio. We'll be right back.
Hi, folks. It's troubling times, and fear is pushing emotions, which in turn pushes health the wrong direction. Do you ever get an ache because life is uneasy? Try Life Change Tea at GetTheTea.com. Life Change Tea works on your digestive tract, helping to move food through quicker and comfortably so your health is spot on. Life Change Tea may not help with world issues, but it will help with your digestive issues. A glass a day helps keep the intruders away. So, change your life today. Log on to GetTheTea.com. That's GetTheTea.com. If your health game is off, get on by ordering Life Change Tea. GetTheTea.com. And while you're on our site, look around at the great non-GMO organic supplements. And if you're a sales shopper, go to our specials page and see what's for you. I've been drinking the tea for 12 years, and I'm sure glad for its health benefits. Again, that's GetTheTea.com. GetTheTea.com. The tea that makes you go.
When you're in the house for longer periods of time, you can see them flying or running across the floor. Ooh, yuck. They're unhealthy, gross, and disgusting. Bugs. I loathe bugs. We keep a clean home, but occasionally bugs show up. Well, I found something that is tougher than bugs. Orange Guard. On contact, it kills hidden bugs, including ants, roaches, and fleas. Plus, Orange Guard is a residual repellent. All of the ingredients of Orange Guard are on the FDA generally recognized as safe list. Orange Guard may be used around food, humans, and pets. It comes with a 30-day money-back guarantee. Orange Guard. Available at orangeguard.com, Whole Foods, and Ace Hardware.
The Liberator Rocket Heater will heat your home for free. The highly efficient Liberator Rocket Heater has no moving parts. It's safe and strong, constructed of quarter-inch steel. So like all things made in the USA, it's built to last. Uses any kind of wood, sticks, even scrap in its gravity-fed firebox. And it heats workshops, homes, garages, outbuildings, industrial areas, and barns. Watch the video of this blast furnace stove in action. Visit RocketHeater.com. That's RocketHeater.com.
Are you intrigued by Paranormal Talk Radio? You'll love the new Paranormal Radio app from TalkStream Live. You'll find a great selection of talk shows covering UFOs, ghosts, strange phenomena, and much more. Download the Paranormal Radio app now and start listening to the very best in paranormal talk entertainment, including the network you're listening to right now, the Paranormal Radio app. Free in Google Play and the iOS App Store.
Hey everyone, this is Nick Redfern and you're listening to Sky Tour Radio with Mark D'Antonio on the KGRA network, and so are the Men in Black.
Mainstream media's most wanted. KGRAradio.com.
Hey, welcome back to Sky Tour Radio. This is Mark D'Antonio with Daryl Mason and Amanda Curran. You like the echo? And the phones are open, so if you want to give us a call, that's the number is 85-KGRA Live. That's 855-472-5483. We await your call, and happy to talk to you. Now, Amanda, I know that there's some more questions, so before we take calls, why don't we get some more of these questions underway, shall we?
Okay, you saw them. Okay, let's see. I was skipping all over the place. Galaxy wanted to know about interstellar travel. Would the best way be to go by asteroid to reduce radiation exposure?
I'll go by asteroid. You know what? That's You know what? I saw some of that. I got an idea what that question was in the chat earlier. Not in the chat, but in what you sent me earlier, Amanda, in the briefing. I'm sorry, you said it to me actually in the break. And I thought about it and I was like, what does that mean? And now when you say it, I was like, you know what? What a good idea. Because this is Galaxy, you said? Who asked the question?
It's Galaxy, that's that, yeah.
Yeah, Galaxy, well done. That's a good question. And the reason that you ask is because you heard what we said about the moon and being able to be safe from the radiation within the lava tubes. If we could get an asteroid to go interstellar, we would absolutely be a lot safer from, in fact, radiation from the stars, not just our suns, but from other stars that we might be entering a star system with. Now, that brings up the question, was Oumuamua such a spacecraft? Ooh, what an idea, huh? Now, I don't think it was.
Some people described Oumuamua as the size and shape of an aircraft carrier.
Yeah, I mean, it was actually a little smaller than an aircraft carrier, I think, right? It was like 700 something. Well, we don't know, actually. We have some ideas, like it's about 700 feet long, 70 feet wide, kind of a thing.
And didn't the name mean messenger?
Well, we named it, of course. But it was a messenger from afar, basically, Hawaiian, Oumuamua. Yeah. And, that was an interesting interstellar asteroid. Now, if it was indeed a crewed vessel, that is CREWED, not CRUDE, but crewed, as in people, versions of us or other creatures were inhabiting it, then I would imagine they would have tried to make some contact, and I think that would be a great idea. But it just came through and left. So the possibility that, again, Occam's razor, the simplest explanation is the probably likely one, that it was just an interstellar asteroid might very well have been it. But if we could go interstellar and we could muster up the energy to do it, going with some type of shielding would really be a good idea. Now, there are some caveats to interstellar travel. There is a way, for instance, to make sure we don't collide with anything. That is a variation of the Alcubierre drive that we talked about before. And this process is something that requires a lot of energy, but it is dimly plausible. So there is a funded lab to explore the possibilities. Anyway, but it's just a great idea. I love the idea of heading off in an asteroid, primarily because there was a Star Trek episode about that called For the World is Hollow and I Have Touched the Sky. It's a group of people that have lost track of the fact that they actually are inside an asteroid. And this asteroid was actually heading toward a civilized world. And they had to make this asteroid deviate from its path for it to survive. And, of course, they get inside the asteroid and find out that there's an entire population in there that serves this asteroid's quote-unquote god, which is the mechanism which controls the asteroid. It was an episode with Captain Kirk, as William Shatner and so forth, the early Star Trek, For the World is Hollow and I Have Touched the Sky. Look it up. You'll see what I mean. Next question.
I'm sorry. That was the one with the old man was trying to talk to him, and every time he tried to tell him something, the so-called God made him hurt really bad. And the hot-looking woman, she was their leader. She'd go commune with the artificial intelligence God thing, and it would impart information to her.
It sounds like you're confusing several episodes.
I may be. That last part sounds like Spock's brain.
It actually sounds like, with Spock's brain. And
anyway, I'm sorry. Carry on with your questions.
Actually, that's good, though, because you make me think of Star Trek. And we all love Star Trek. Come on, we're all nerds. Okay? Even all of you in the audience are probably nerdy. I'm sorry. You're all saying, I know what episode that was. Daryl, it wasn't that. It was Spock's brain. Oh, he got it, No, but that's cool. Amanda, we got more questions there?
Oh, no, we're caught up for the moment, but I am keeping my eye on chat, so...
Awesome. So let's take a call, shall we?
Yes.
Okay, so let's all hold our breath. You ready? We're going to take a call now.
See.
Here we go.
So excited.
Hello, you are on the air, and who might this be, as if we don't know?
Hi, Mark. This is Ronald from Minnesota.
Hey,
you
Ronald.
already know that, though. You already knew that. The chat room's kind of rough tonight. I have to get in first, so Kathy's stealing my lines, and...
What? No one's stealing anything from you, Ronald. Stop. So how are you?
Yeah,
What's going on?
my gold.
How can we here at SkyTour Radio help
Yeah.
you, Ronald, who lives in a
Hello
postage
to-
stamp
hello
town
to-
in Minnesota?
Hello to Mark, Amanda, and Daryl. I'm glad that you're back and feeling better.
Hello,
So,
Ronald.
Hi, Ronald.
I don't think you were, you had, Daryl was under the weather a little bit, like I was, I guess, a little bit. 4 days I was out. 2 days I had chills and it was 80 degrees outside and I was cold. I didn't quite understand that one, but anyway. I got over it though. I got through it. I fought it off.
Pretty good.
So now the question I have for you, Mark, is two questions. Completely two different things. So, but the first one we touched on a little bit was the laser light, the green. Why green? Why not red? Why not blue? Why not yellow? What is green a tighter bandwidth? Is that why green?
No, it's just the atmosphere is more transparent to green.
Oh,
It really is that simple. I mean, the atmosphere is just more transparent to green. The other wavelengths get scattered much more easily. We know blue would be very bad because blue is scattered by the atmosphere very easily. That's why our sky is blue.
Oh, yeah. Okay.
Yeah.
All right. Fair enough. That makes a lot of sense. And then the other one is the dark cloud in front of the star. So when you see that dark cloud, that has to be material. But now, then when we talk about in space, we see dark matter in space, like the tripod, however you say it. You have the dark lanes, which are actually in front of the nebula, correct?
That's correct. Yeah. You listen. This is what's good. This is what I like about, people actually listen to what we say. You're right.
we actually listen when you're talking. We
Yeah,
might
you
be
do.
asleep,
That's
but we're
fantastic.
listening.
I'm very happy
We might
about
be
that.
asleep.
That's correct.
We learn a lot when we're sleeping. I heard that, so I don't know. But, no.
Are you saying you
Anyway,
sleep through our show?
No, I don't. No.
Okay, that's a good answer.
That's a lie. That's a total lie. I don't do that. No, but thank you again for everything you do, and I can't wait till you get that one in Arizona up and running, and I'll be ready to come and visit you when you get all settled in.
Absolutely,
So-
and I have to thank Marianne, who's in Arizona, who actually is helping tirelessly. And I want to thank Tara in Arizona as well, who is actually going to help us with the artistic look of the observatory. And people are just coming out of the woodwork to be helpful with this project, and I am so humbled and just like overjoyed. People want to see good science, Ronald. And so we have this Arizona observatory is SkyTour Livestream West. We have East here, and SkyTour Livestream West is going to have our telescope in there. We have another pad or two that we're putting in the same building for telescopes. And one of the other pads is already taken. There's a group that already wants to use that pad and rent that pad. So it's going to become quite a beautiful little setup out there.
Now, will you have an option for, say, like, will anybody, like, say, during a certain time of the year or maybe throughout the year, will you have it where somebody can send in some donations and be able to use, like, say, the telescope or whatever they want to look at?
As a matter of fact, I'm actually working exactly on that plan to have supervised discovery nights where people can come in and say, "Hey, I just want to look around the sky. What do you recommend? Will you hang out with me?"
That'd be fun.
And the answer will be yeah, and they will be in control of the telescope. That's exactly right.
Wow, that'd be good. All right,
Well,
I
hey,
can't
it's
wait
about
for all that
outreach,
to
right?
happen.
We want people to experience what it's like to actually use a telescope under a real, truly dark sky. And that's just what we're going to do out there. And so, our Discovery Night's going to be for people that want to come in who may not have any experience with telescopes, but know something about astronomy and say, I want to see that supernova that occurred. And can we see that from there? And if they answer, and this will all take place through a Zoom or a Skype discussion where we'll say, okay, what do you want to do? And let's set up your observing itinerary, and we'll show you what to look at. And they'll be able to figure out what they want to see. So when they come in, they can hit the ground running and say, okay, we're going to 5 different things tonight. And I'm going to take 5 different sets of pictures that I can then take and have for myself. And all the pictures are free anyway. Everybody gets the pictures no matter what anyway. But for the person running the telescope, they get to see what they want to see precisely and not have to wait or hope that maybe we can have time to show it to them.
That'd be awesome. Well, thank you for all that you do, and thank you, Amanda, for helping out on all of your shows, and thank you. Of course with Mark here, and thank you, Daryl, for helping Mark out and helping whoever else. I guess me and Kay or whoever you sit with. I always hear you on a couple of shows, so appreciate your input and your knowledge. And I always learned a lot when I listened to the three of you and listened to Bill and listened to Paul and Keith, and Paul doesn't say much, but Keith does. And so, I always learn a lot from you guys, and I appreciate everything you do. And just thank you a lot for all your hard work they put into it. And I have your book, by the way. I have your the large format on your book.
You got it, huh?
The Unpopulated Universe, yeah. And so when I do come and visit, when I do come and visit you, you're gonna autograph that for me.
I'll stamp you. That's not a problem. I'm glad you bought it, and I'll make sure you get a signed version.
Oh yeah, good deal. All right, well, you guys have a great night and have a good week, and we'll see you on the SkyTour live stream. All right.
Sure thing. Thanks, Ronald, for the call. And just for the record, I just want to make sure everybody understands that it's Daryl and Amanda that keep me going. Okay, not me that keeps them going. Okay, they actually they're pivotal to this entire thing.
Well,
so
everyone works together. Everyone works together.
I'm just a big mouth. But thanks for the call, Ronald.
Yep. Yep. Thank you, Bill. All right. Good night, everyone.
Good night.
Bye.
See ya.
And the big thank you goes out to people just like Ronald. I mean, he comes back every week. He's always first in line to call. He always comes to the live streams, and he's listening. And he's learning, and he asks intelligent questions based on other shows that we've had, and that matters. That that shows you guys care and continue to support us. So thank you. I think the chat, the listeners are what keeps the show going, really.
Oh yeah, there's no doubt about it. You guys are really quite something. I can't say enough. You guys really have driven me. I didn't know that I was going to have a radio show. I never thought I would. I didn't know I was going to have an observatory, never mind 2 remote observatories. All right. But once I began to put this all together and realized, I'm going to be honest here and brutally honest, 5.5 years ago when I had the surgery that went sideways and I ended up blind and quadriplegic, right? I had to come back from that. There's still some residual things in my vision. I can still drive and do everything, okay? But there's still a few residual spots in my vision that are at just the right spot where I can't do the visual effects and the model making stuff exactly the same way that I used to be able to do it. And what I'm doing is I'm taking the astronomy and I'm making that the first and foremost thing that I do. Because I've always been an astronomer who just happened to have that business too, because that was the thing paying the bills. But I want to make this astronomy pay the bills, and I want to have these things happen. And so that's why I'm doing it, because this is something that I can do easily. I don't have a lot of things I have to do to prepare to do a show on SkyTour Radio. Yes, I write a show. I do it every week. Why? Because I think it's important to actually collect the thoughts so that it doesn't sound disjointed when I'm on the air. But it's very important to actually, pay attention to also your own capabilities and what's changing, And what changed in me is that it's harder for me to do what I used to do since the early 90s. And yeah, I started that business too. But And it's beautiful, and I keep doing it, and I have a lot of projects to do for that still, but I'm also working on supplementing it with other things that are a little bit easier for me to do because of the fact that I can't see as well as I used to. I can still, like I said, drive. I could probably even fly a plane if I was a pilot, but maybe not. But still, I could still do all the things I did before, except when you have to do these critical measurements, then that's where this goes wrong. Making critical measurements, because I can't see in that one spot in my vision where I have to be able to look at the measuring tape or look at the calipers. There's one spot that's missing, and that spot doesn't affect anything but my job, and that's unfortunate. So it takes me 10 times as long to do something as it might normally. So that said, I'm not making excuses. I'm not lamenting, because I'm very pleased with how everything turned out. I'm still here. Didn't have to be that way, but it is, and I'm pleased. So I will not ever complain about it, but I will just say that I want to take my astronomy and take the world of astronomy, because people, and bring it to people, because people have expressed an interest in seeing more of it. And I absolutely love it. I absolutely love it, and so I have to thank the people that have supported Sky Tour Radio, the people that have supported Sky Tour Livestream, all of you listening right now. I count you as family of a sort, because you guys have been here all the time, every day, every Sky Tour Livestream, and also on the Sky Tour Radio. Many of the people that are in the radio show and listen to that also watch Sky Tour Livestream, and you're used to hearing from Amanda and Daryl and me in both venues, and I think that that's testament to the fact that you guys want to hear the good science. And if I don't know something, I'm not going to make stuff up. That's not me. I will tell you I don't know it. I'm not embarrassed about that. There are certain things I don't know, and that's okay. But if I do know something, I'll mention what I do know, but I won't go beyond what I know. That's not right, right? But so the thing is, it's really kind of interesting, when I look back at this and say, Sky Tour Radio is here because of Bill, the producer, okay, and a little bit of Keith from P&K Space Imaging. Sky Tour Livestream is here, again, because of those two jokers. Said, you got to do this, you got to do that. I'm like, I don't want to, no one's going to watch. I'm not going to do a live stream from a telescope. What are you talking about? Who does that? And then I watched live streams from telescopes, and I thought, wow, a lot of people do that. I have so much to say. Maybe this would be good. But I didn't want to do it on my own. I didn't want to make it like this is the Mark D'Antonio show. I don't need that. So that's why I asked Amanda to be the co-host of Livestream, and she also wanted to be the co-host of radio, and I thought that was great. And then I thought, well, you know what? Daryl is a phenomenal astronomer. He won't say so. He'll go, make all these, complaints, and he'll tell you to stop and all that stuff. But the bottom line is,
stop.
And there it is. But he deserves the kudos, and I think that that's important. All right, and people like that, they're just little gems hiding in the background, waiting to share an immense knowledge that I think is really good. His astronomy comes from a totally different direction from mine. He's an observational astronomer. I am, what's the word? What would I call me then, Daryl? If you're an observational astronomer, what would I be?
A degreed astronomer.
No, because that sounds haughty. I'm not like that.
Wow. I'm a School of Hard Knocks astronomer, okay?
Okay. A School of Hard Knocks astronomer, yeah. Someone who's run up against things that I've never seen, with like a telescope that won't cooperate, or, trying to build this amazing dual binocular telescope you've built. If people see that, they're going to say, wow, this guy knows what he's doing. I could never build a binocular telescope. Daryl built a binocular telescope. Do you see what I'm talking about? Okay.
Well, that came from I was an industrial mechanic of various sorts for 40 plus years, and as part of that I learned design and fabrication as part of my job, and I took classes in it. And also, I was an art major first time in college, so there's my creative side, and I just kind of put it all together with my love of astronomy and started making telescopes and stuff.
Mm-hmm. You make it sound like it's just nothing, but being an astronomer, I know what it's like. When I got my first book in astronomy, you folks, many of you know this, I was 9 years old. I had actually just had an operation where I had to be out of school for like a month, and I was going stir crazy. So my parents bought me a telescope because I wanted a telescope. I was outside with that telescope, even when the weather wasn't clear, just looking at distant radio antennas, anything, just learn how things far away looked up close. What a great time, And so I ended up doing a lot of that. And I spent so much time spending so much time with these telescopes. I ended up buying another one later, a Celestron 5, as a matter of fact. And for those that know what a Celestron was, the early Celestrons were orange tubes with really good optics. And I'd open the case and I'd smell the foam and the telescope itself. And that was right there. That spoke of high quality because it was such a beautiful telescope. And I sold it eventually. Really, really didn't want to. And I bought a much larger telescope for the amount of money I got for this much smaller one because it was a collector's item. And then that started the career snowballing. And, when I finally went to college, I got my degree in astronomy. I was in graduate school for some period of time, actually doing computer science, actually. And I felt that computer science was taking me the wrong direction. I didn't like the direction I was going with computer science because it was going to mean that I was going to be behind a monitor all the time. I didn't want that. I wanted to be hands-on with telescopes, just like Daryl's doing. Well, it turns out that I ended up going more into the computer science anyway. And now the benefit that's given me is that I can now control all my telescopes from behind the computer screen, and I do it now. And I figured out a way to make sure that everybody sees what I see, plus additional little cool production value things like moving around the screen, pointing at things, and they can see what I'm doing, and they see me then on the screen. They see other people on the screen too sometimes, and so they actually get to see what's going on, and they learn a little bit more about astronomy as if it's more multimedia for the YouTube generation, right? So I make it this way. Just so people have a better time. And when they come in, they say, wow, that's cool. I get so many people who come in and say, I put you up on the giant screen in the living room. It's like, wow, that's really nice. That's cool. Then I get people who come in and say, I just watched you on Discovery Channel, which, I do a lot of those shows. And that's cool. Thank you. That's really kind of you to say that. But, I forgot what I did for that particular show. But, I've been on dozens of them. So I'm like, hey, that's fun. But so in that sense, I guess that gets you the attention that people want to. It gets you the attention of the people, and then what comes down to is, you once they're in the door, well, that's all on you now. You can't just say, hey, welcome. What do you want to do? No, you gotta say, hey, welcome. Let me show you something cool. Now you take them out into the universe and take them for a ride. Take them for a cosmic ride and show them really cool stuff. And I couldn't do it if I didn't have Amanda with me, and I couldn't have Daryl with me. I could do it myself. I have done it myself. But something? It's much more fun and much more enjoyable when you got other people with you, right? And so Sky Tour Radio is the same way. And Daryl will tell you this. I was after him for quite some time to join us on Sky Tour Radio. And initially he wasn't sure he wanted to, and a little hesitant, and I get it. I get it, and I respected him for that. But the time came where I basically asked him one more time and thought, don't you think that you could really join us, Daryl? And he said the magic words, I'm thinking about it. You remember that, Daryl?
Yeah, I remember. I was happy enough to do it. I just didn't want to put anything down on paper, or make a commitment I couldn't get away from.
Yeah, well, now the way it is you join us on Sky Tour Radio, and you know more than you think you know, just like I guess I do. And no matter what I write for the show tonight, we actually got into what should have been the first 10 minutes of our show. I have the other hour and a half still sitting here that we hadn't gotten through because we had all these wonderful questions. We had interaction with Daryl and Amanda. And as usual, I wrote way more than I needed to. But the fact is, if I didn't write it, then I wouldn't be ready. And I always have to be ready for all of you guys. So the bottom line is, we're done for tonight. We're out of here. We're coming home, Gracie, and we're going to end up, coming back to you next week. So on behalf of everybody at KGRA and Daryl and Amanda here, I want to say to all of you, I hope you have a good evening. And this is Mark D'Antonio from Sky Tour Radio signing out for now. And we'll see you next week. And don't forget, when you go out, keep looking up.
Except while you're driving.
Oh, I love it. She said it.
Good night, everybody.